aliens were to come down from space, they wouldn't think of us as humans necessarily. They would talk about us as being a hybrid species because we have as many microbial cells as we have human cells.
Dr. Emily Leeming, welcome to the podcast.
Thanks for having me. Great to be here.
And so you're obviously in the UK, but you spent a bit of time over here in Australia, in Melbourne, actually, where I am. Tell our listeners about that.
I did my master's in dietetics at Monash in Melbourne, and I was there for 2 years and absolutely loved it and was very, very sad to leave, but I got lured away by the promise of a PhD at King's College London in the gut microbiome and diet. So that's what took me back to the cold, grey weather of the UK.
Of old blighty. I tell you, it's interesting because when you move over here to Melbourne, you're like, oh my God, the weather is amazing. And all the locals complain about the weather, right? And then you go back to the UK and you go, this is what shit weather really is.
Yeah, it's all about perspective. I think if you're comparing to Sydney, then, it is a bit of a change in Melbourne. But in comparison to here, it is balmy. And yeah, I miss the food and the people. And I still have lots of very good friends who live over there. So yes. Yeah,
very cool. So look, as you said, you did a PhD in looking at the gut microbiome. Just tell our listeners a little bit about the study. Why did you get interested in it? And what was your PhD thesis on exactly?
So I got really interested in the gut microbiome years ago from a book that came out by Dr. Julia Enders, which was called Gut. And that really stirred up my love of science again and getting really passionate about this very exciting new area of science and research. Because my first career was actually as a chef. So I did my undergrad in nutrition, worked as a chef for many years, thinking that's what I wanted to do. I worked with people who had dietary intolerances or specific dietary preferences. And then I read this book and just realized I was then, getting very, very excited about the science again when I did my master's, and then found this PhD at King's College London that was specifically looking at whole foods and the impact of food on the gut microbiome and health, which was just, the most perfect fit for me. So I did that at King's College London, and then I now still work as a researcher. I'm a research fellow at King's College London, where I'm still researching diet and the gut microbiome. And it's just such a fascinating area of research because only 20 years ago, we didn't really know much about the gut microbiome. There weren't really many research papers, but we now have this rapid escalation in technology that has now allowed us to have, I think, when I last checked a few months ago, there was about 60,000 research papers on the gut microbiome and rapidly increasing. So it's fascinating. Great area of research to be in.
I knew it was a crazily expanding area of research, but I had no idea there was 60,000 publications on it now. Yeah. That's mental. Tell us a little bit about your PhD studies or experiments. What exactly were you looking at?
So I was more looking at, so we have a cohort of twins, which effectively means that we've followed them for many years. They're adult twins, and then we've collected data from them at different points. So what I was looking at was how can we look at the diet data that we had from them and how could we look at the microbiome and the health data in new ways using what's called computational analysis. So this is basically just using machine learning or kind of, those fancy, machine techniques to be able to explore, okay, how do we picture someone's diet? Can we look at it in a slightly different way, a different lens, to then understand this relationship with the microbiome? So I think we all really recognize how complex the microbiome is, but actually nutrition gets slightly, forgotten of being this equally complex part in this relationship too. We all eat in very different, unique ways. Our diet kind of changes day to day. So how can we, apply some of the tools that we have, for example, when we're looking at the microbiome, where we're kind of using this computational analysis, can we apply that in a similar way when we're looking at diet? And can that then progress our understanding of that relationship? Because we're using those techniques in a way that helps us to explain this relationship better.
And did you find anything surprising or interesting in the PhD studies that you did?
I would say when we looked at plant diversity, we had some really interesting signals around fruit diversity, particularly. This is kind of unpublished data as yet. We still need to kind of get that published and out. We had just some really interesting relationships with looking at particularly kind of heart health and kind of metabolic health. And it was really kind of good, just really lots of kind of deep dives into how we're understanding this and how we're looking at the methods and making sure that we're having a very consistent approach to understanding what we need to know and how can we kind of further our knowledge in this field.
So let's talk a little bit about the microbiome and how it develops in an individual. So if we go right back, if you just think of the timeline of existence of a personal human being, what starts the ball rolling in terms of the composition of their microbiome? And then if we just kind of go through early life, what are the big things that will have an influence on it?
Yeah, so there was a few papers out in the last couple of years that suggested that perhaps your gut microbiome, your first dose of microbes, happens when you're still in your mother's tummy. That is still kind of slightly refuted, but most of the scientists would say at this point that we don't necessarily think that's necessarily happening. We're not sure what's happening there yet. And actually what we really have good consensus on is that you get your first dose of microbes when you are born. So if you're born by vaginal canal, your first dose of microbes will be from your mother's vaginal microbiome, but also from her gut microbiome as well. If you think of childbirth being this kind of messy process, there are a lot of different elements mixing around, and that's actually a really great thing for your baby's gut microbiome, because that means that your baby's getting that dose of microbes from both your gut microbiome, which will be kind of, some kind of fecal matter, but also from the vaginal microbiome. So that's a very much, if you're born by vaginal canal, that's your first dose of microbes. If you're born by C-section, it is a slightly different story. So that first introduction, that first dosing and seeding of your gut microbiome is actually from the skin microbiome of your mother and your father, but also the nurses, anyone else working in the hospital, the doctors, but also from the hospital environment as well. So if we think about that, in fact, we live in this very microbe-rich world. There are microbes over every surface. So you're picking up also microbes from the hospital environment. So that can mean someone can start life with a very different set of microbes than someone else.
Just on that point, is at the risk of oversharing, I have two kids. The first one who was born with an emergency C-section, and then the second one who was a VBAC, a vaginal birth after cesarean, and actually was a home birth in the pool, in a little sort of home pool or tub, massive tub. And when Oscar came out, all the messiness comes out. And it was really interesting because the lady who was doing the home birth, she said, don't wash him. Just leave that stuff to dry on him and just leave it there for days. Because that, as you say, has a massive influence, doesn't it, on the composition of somebody's microbiome right out of the gate.
Yeah, I don't know about specific birthing techniques or modes, but I definitely think it's that first dose of microbes that can kind of kickstart. And it's not to say that that's a full picture. I think there's many different factors that influence and affect your gut microbiome, but that does mean that obviously you get that first starting point of one of the many different points that your gut microbiome is influenced across your lifetime.
Yeah, interesting stuff on Melbourne. So Melbourne, I'm not sure if you're aware of this, but has the highest rate of allergies anywhere in the world, and has also got the highest rate of cesarean section births anywhere in the world, which is just this kind of crazy quirk of Melbourne, that there's so many cesarean sections, but that link. What do we know about these links with that early life exposure and risks to things, particularly like asthma and allergies?
Yeah, so really it's that first 5 years of life, your gut microbiome is closely developing along, it's that first starting point of it. We're really kind of forming into something that then becomes more like an adult-like gut microbiome. What happens is that's also happening very closely in tandem with your immune system. So there are, 70% of your immune cells are found in your gut. And there's a very close relationship between your immune system and your gut microbiome. Your gut microbiome effectively helps to train your immune system to spot and identify, the bad guys that you don't want there, but also to avoid attacking any of the good kind of harmless kind of citizens that you have in your gut, but also kind of cells in your body. You don't want them to attack that either. So I kind of talk about it a bit like if you train a guard dog, you want the guard dog not to attack the postman. You want them to attack, the the people coming
Burglars.
The burglars. So that's where your gut microbiome plays a very close role with your immune system, and they're very much in tandem throughout your life. So what we say is if your microbiome, it's that key development period in that first 5 years of life, that's also, very important for your immune system and that ongoing relationship. So what we think there is this relationship in terms of if you, for example, have a lot of antibiotics when you are in that kind of period of life, yes, please do take them if they are life-saving medication, if they're really necessary. But if you're having them when they're not necessary and they're kind of excessive use, that can have then a knock-on effect on your gut microbiome and its development. And what we see is that you can potentially then be at higher risk of obesity, of autoimmune diseases related with your immune system, with allergies and intolerances. And, we think that this is one of the reasons this might be happening is because of the gut microbiome at this key period of life, whether that is related to being C-section, whether it is, being formula fed rather than breastfed with breast milk containing special components which specifically feed the good gut bacteria, or this kind of excessive use of antibiotics. So there's a lot that we still wanting to tease out and understand about this relationship, but there does seem to be this relationship there.
And look, your finger will be much more on the pulse in terms of the current research on this. But I remember reading years ago that particularly then the environment that a child is brought up in has a big influence, like how much sanitation. You see these mothers who are just, or dads who are just constantly using those little cleaning wipes and cleaning gels on their babies and just clean and have this super clean environment, versus then farm kids or kids who are free range kids who are just brought up and play in the dirt. Things like whether or not you have pets, exposure to animals, what's the recent research or the latest saying about how much all of those things influence the development of the microbiome?
So that's called the hygiene hypothesis. So at the moment, It's a kind of theory that our way of modern life is effectively having a negative impact on our gut microbiome. But we do see this when we see differences, for example. So we see differences in the gut microbiome of people who live in the countryside, tend to have a more diverse gut microbiome than people who have, an urban environment. So if you think there's air pollution, I sadly live in the city. What am I doing? And then you've also, we're spending a lot of time indoors, so we're not having that interaction with nature. So if we think back to the fact that microbes are all around us, soil is particularly dense in microbes, and just not having this interaction with nature as well. We also see a difference in people who have pets. So for example, if you own a dog, you're more likely to have certain types of bacteria, more types of certain bacteria than other people who don't have pets. We're not sure yet. There's some kind of signaling about whether your microbiome might be more diverse if you have a pet versus if you don't, but we're still trying to understand and tease out that relationship. But I think there'll be more research on that soon. So I think there's and I think it's really recognizing that, we spend a lot of time indoors. We are sedentary. We are kind of over enthusiastic with our antibacterial spray. So I think we've been brought up to think that all bacteria is just bad bacteria. And yes, it's really important to have hygiene on surfaces, particularly in kitchens and food prep and things like that. But actually, are we overly using those things? And I think, there's a study that kind of highlights this important the relationship with soil. It's really interesting, where the participants effectively dipped their hands into soil 3 times a day for 20 seconds, and they rubbed their hands in the soil and then just rinsed it off with water. And over a course of a couple of weeks, their gut microbiome diversity improved and increased.
Wow.
So this is a signal.
Wow.
A more diverse gut microbiome is effectively considered a more healthy gut microbiome. And that is because the researchers thought that was effectively improving their skin microbiome, which is, again, another type of microbiome, lots of different sites in our body, lots of different microbes. And then that was then introducing new microbes into the gut. Because if you think how often we're touching things and introducing it to our mouths, and, there'll be constantly this relationship between our environment and ourselves where we're bringing new microbes in.
It is a real fascinating area. And I want to come back to the diversity a little bit later on, but just give people a sense, what is the latest thinking about how modifiable your gut microbiome actually is? And is it more modifiable when you're younger, or is it modifiable all the way throughout your life? And to what sort of extent can you modify it? What do we know about this now, currently?
So in that first 5 years of life I mentioned, your gut microbiome is in rapid flux. So it's rapidly changing, and it hasn't kind of settled down and become more stable. We talk about this kind of more adult-like microbiome. We do think that actually it's still, effectively still developing over your teens, but it's just at that more stable point. And when I say stable, I just mean that, say you got a stomach bug, your gut microbiome is much more resilient to just not being completely kind of overhauled by this kind of bad bacteria coming in. So it's actually a really great thing. It's very protective to have a stable gut microbiome, but it also means that it's harder to then shift it for the better as well, because it's more resilient to change. What happens is then throughout life, we're still able to shift and change it because it's a living ecosystem. We've got to think of it almost like this pet in our gut that we're looking after. And what we see from the research is that actually within 3 days of changing what you're eating, we can see changes in the gut microbiome. So it's, there's rapid changes happening very quickly, but it's also making sure that those changes are very consistent in the long term, because it's very much acknowledging that we also need to shift that core stability as well towards a kind of healthier profile. And it's not just that kind of early changes that we see in those first 3 days. I very much talk about the gut microbiome as, yes, we can change it, but we need to step back and think about it from a perspective of months and years, rather than like being super hyper-focused on one meal or one day. One of the biggest ways that we can change it is through diet, because what we eat is effectively directly impacting on the gut microbiome, with our gut bacteria living in our large lower intestine.
Yeah, no, I again, I'm going to come back to the eating thing. I think that's going to be a huge part of it. But just give people a little bit of a sense of the role now of the gut microbiome in health and disease. I mean, I remember reading studies years ago, and again, I'm not up on the most current stuff, but looking at people with both obesity and with diabetes had different balances of bacteriodes and firmicutes. And there was talk about, I can't remember which one is more energy harvesting. What do we know? And also the whole gut-brain microbiota axis, and how the composition of your microbiome can affect your mood, and also how psychological stress can affect your microbiome. Give our listeners a bit of a sense of just what we know about this right now.
Absolutely. So we know that everybody's got a microbiome that is unique to them as a fingerprint. But actually what we really see is that, if you grouped lots of different people together, that people who have a healthy microbiome tend to kind of have, we're able to kind of see them as a certain profile. But in comparison to comparing them to someone who has a disease or a condition, have a very different gut microbiome. And this is what we're seeing. We're seeing that if you have anything from depression or Alzheimer's disease, or kind of a different condition like type 2 diabetes, you've got a different gut microbiome than people who don't have those conditions. And generally, when we're talking about a microbiome with people who have an illness or condition tends to be not always the case, but they do tend to be less diverse and less different types of gut microbacteria. Or it could be that they actually have more pro-inflammatory types of gut bacteria, which is necessarily, then you're potentially having a cascade of these molecules that they produce being pro-inflammatory and having a knock-on effect. We also see, for example, in depression, that there are lower levels of what are called short-chain fatty acids. Now, these are specifically types of molecules that your gut bacteria produce when they feed on fiber. So I talked about, the gut microbiome. A lot of people say, oh, it really matters, what the names of the gut bacteria are. And I say, well, actually, it's actually not necessarily who they are, but what they do, it's their skill set. And what we really focus on is actually these molecules that they produce. So they can produce, up to 50,000 different types of molecules. But particularly when they feed on fiber, this plant roughage we get from beans, vegetables, fruits and legumes and whole grains, they can produce these special molecules called short-chain fatty acids. And these short-chain fatty acids are really important for the health of our guts, but also for the health of our brain. And so seeing them in lower levels in conditions like depression, is a signal of this potential involvement of our gut microbiome in this gut-brain axis. So to talk about the gut-brain axis, really exciting early research in this area, and I think it's really a very rapidly progressing field that's just only expanding. A lot of all us microbiome scientists are fascinated by this area of research, and it's only building and growing. And I think in the context of how we think about this relationship between the gut and the brain, or particularly the gut microbiome and the brain, we also need to kind of almost go back to thinking about evolution to really understand how important and significant this might be. Because I think quite a lot of the time when I talk about the gut microbiome signaling to the brain, it can seem a bit baffling almost, because how can these microbes that we can't even see that live in our gut, it seems almost a bit fantastical that they signal to our brain. But actually, if we think back to evolution, before humans even existed on this planet was so microbe rich. This was owned and dominated by microbes. So therefore, we have co-evolved with these microbes. There's not been any point during evolution that we haven't had to kind of cohabit with these microbes throughout our entire evolution until up until now. We're still interacting with microbes every single moment of the day. And I think also, I like to say about if aliens were to come down from space, they wouldn't think of us as humans necessarily. They would talk about us as being a hybrid species, because we have as many microbial cells as we have human cells. So I think in that perspective, that really helps us to understand that microbes are involved in every aspect of our brain development. And actually then, that just puts us in that perspective of actually, yes, now we're understanding that these microbes are signaling to our brain directly through what's called the vagus nerve, which is a long wandering nerve that connects your brain to your gut, and also through these molecules that are produced, so those short-chain fatty acids, but also others, through your immune system. So again, we're going back to that relationship with your immune system. That's, sending messages and signals to your brain through your immune system, but also through kind of hormones and neurotransmitters as well. So your gut microbiome is involved with our brain, and it's very exciting area that we're just understanding how this can affect our mood, our cognition, but also our behavior as well.
Yeah, it is. For me, it's a fascinating, it's like it's a new frontier, a whole new frontier of research. I want to come back to the short chain fatty acids and the links with mood and particularly depression. Is it one specifically? Like, is it butyrate, or is it all of them? Butyrate, acetate, propionate, which one, or are they all implicated?
So that they're all important. And I think generally when we talk about these short chain fatty acids for our brain health, they're also really important for our blood-brain barrier. This is really particularly where we get kind of excited about short-chain fatty acids. So they're able to cross into the brain, signal to the brain, but also it's about keeping the health of this blood-brain barrier. So your blood-brain barrier is effectively a protective fortress encasing your brain. And this fortress has gates in it that helps to let healthy molecules through nutrients through, but it also helps to keep the gates shut against harmful molecules and invaders. So that's where these short chain fatty acids are playing a particular role in whether it's specifically different types of short chain fatty acids. Butyrate is one that we tend to look at the most, but they all have kind of an anti-inflammatory profile and kind of a signaling in different areas of the body. Even, lots of different interesting research, even around propionate, for example, in terms of helping to kind of ease food cravings and that through that kind of signal to the brain. So I think there's a lot more for us to kind of unpick around, what's happening where. I think when we talk about this area of research, it is in a way still slightly a black box because it's very new and exciting. But some of those relationships are really getting kind of unpicked and even just like last week, for example, we had an exciting new study around the top-down relationship of stress from our brain on the gut bacteria and looking in mice. So mice, of course, are not humans, but they can give us that early signals of what that mechanism might be. Again, we have to make sure that's just whether that translates into humans or not. But what they found was that the stress was effectively shutting down specific glands in the gut. And that meant that those glands were not producing a certain type of mucus that your lactobacilli, which these are really kind of good beneficial bacteria, like to feed on. And then that was having an impact on how many lactobacilli the mice had, which then had a knock-on effect on their immune system, meaning they were more likely to be susceptible to infections and getting sick. So, it's really great to have this research helping us to really do a deep dive into what's happening, because a lot of the studies are if they're in humans, they're population studies where we're looking at patterns rather than necessarily cause and effect. And what we really want is more of these cause and effect studies in humans, but also that's really helped and supported by having these mice studies that show, a cause and effect and what that pathway is.
Yeah, and they give us a pointer on the stuff to study in humans, right? But as you say, we always have to be careful because we aren't big mice, right? But there's a couple of things I wanted to talk about there that you mentioned. So you talked about the blood-brain barrier, but also this other barrier between our gut and the rest of the body. Because I say to people, if we think about it, our entire digestive tract is essentially a tube that is external to the body, even though it's inside us, right? And it's the easiest or one of the easiest ways for pathogens to get in, which is why we have stomach acid. And then when we get down into our colon, we've got this mucous membrane and these villi. So talk to our listeners about what happens. I remember reading a fascinating paper years ago, and the upshot of it basically is if you're not getting enough fiber, some of the microbes that would normally feed off fiber essentially turn into cannibals, and they start to eat the mucous membrane, which then makes our gut barrier more susceptible to being penetrated. We get that leaky gut syndrome, as some people talk about, but then you get an immune reaction. So talk to us about why we need to have particularly fiber and this specific types of fiber. Because everybody hears fiber, right? But for me, when you dive down into the gut, that's where the magic happens, right?
Yeah, so fiber, I talk about fiber as being a bit like Clark Kent, that, it's before Lois Lane realized he was Superman. We've had such a kind of, poor fiber as just being kind of sidelined as being something a bit dull and boring and just kind of helps you go to the bathroom and that's about it. It's actually, it's the closest thing we have to a superfood. It is, so important, not just for our gut microbiome, but also our whole body health. I mean, if we think about it in the frame of a can of beans, 5 grams of fiber is about a third of a can of chickpeas. That's for every 5 grams of fiber you have is related to a 5% lower risk of depression. For every half a can of beans, 7 grams of fiber is related to a 9% lower risk of heart disease, 6% lower risk of type 2 diabetes, and 8% lower risk of colorectal cancer. So fiber is, I'm very big on fiber. And when it comes to the gut microbiome, so effectively, we have in our, when we're eating food in our gut, we are not able to fully digest and process fiber on our own. So it passes through your small intestine, where 95% of the foods you eat, the nutrients are absorbed, into your lower large intestine and right onto the dining table of your gut bacteria. And your gut bacteria particularly love to eat fiber, and they feed on this fiber, and that helps them to produce those special molecules. We mentioned short-chain fatty acids, and it's really this relationship between fiber helping them feed, helping them to grow, helping them to flourish, and helping them to produce these special short-chain fatty acids and other molecules. Side note there is that short-chain fatty acids are really important as well for the health of your gut barrier lining. So that kind of inside wall against the murky matter within that's kind of separating your body. So unlike us, we can pop to the shops, right? And we can restock our fridge. And if we're feeling hungry, we can go and grab a bite to eat. For our gut microbes, if they're not getting, foods that is necessarily coming onto their dining table in your large lower intestine, then yes, they do slightly start to chew the furniture, which is effectively you and your mucus. So this mucus layer effectively acts like a kind of soft, pillowy downing. It was probably more sludgy than that lines your gut barrier lining and effectively acts as a barrier against microbes, but other kind of anything that might potentially be harmful. And it's this very kind of protective kind of lubricant of your gut on your gut barrier lining. So if you start kind of to lose some of that mucus layer, that means that microbes, whether they're good or kind of, necessarily potentially being harmful in this case, can then start to kind of reach that gut barrier lining, which then signals to your immune system that there's something wrong. They're like, your immune system goes into a bit of a panic saying, oh, hold on, there are, trespassers here that shouldn't be here, that can potentially then trespass through into your body, which then again puts your immune system onto alert. And this could be then one of the pathways why we see that having less fiber is then associated with having kind of higher risk of many diseases, because you're then having this, knock-on cascade effect of inflammation. Is that then triggering potentially a higher disease risk? And it's this kind of knock-on pathway. And we've seen this very clearly in mice studies, again, caveat with mice studies, but just trying to understand kind of what's happening where they fed the mice a kind of unhealthy kind of kibble, and they found that their gut barrier lining then became leaky. And then they saw directly that these kind of microbes were then able to pass through and actually travel to the brain where they shouldn't be. So this is trespassing. And then they saw higher levels of inflammation in the mice's brain. But actually then when they switched them onto a healthier kibble, that gut barrier lining became strong again. And they didn't see this kind of translocation of the bacteria or the kind of raised elevated levels in the brain either. Yeah, we definitely I'm very big on the fact that we need to be eating more fiber, particularly in the context that most of us are on average only getting 60% of our fiber needs. So we've really got this big fiber deficit on a daily basis that we need to be solving for not just our gut bacteria, but also for ourselves as well.
Yeah, and I know that studies looking particularly the Hadza hunter-gatherer tribe in Tanzania have got way more diversity in their gut microbiome. I mean, a shitload more fiber than we do, right? So let's now get into the stuff that people can actually eat. And when you talk fiber, are we specifically talking about resistant starch, or is it just any type of fiber is good fiber? And then also there's probably a good point to bring in the role of fermented foods and any other types of foods that we know are good. And then we'll talk about the bad stuff.
So when we're talking about fiber, I'm actually a big advocate of talking about all fiber, because I think really we've got to talk about the health of the gut, the home of the gut microbes, as much as we talk about what foods our gut bacteria particularly like to feed on. So fiber isn't just fiber isn't just one thing. It's many different types of fiber. Resistant starch kind of gets bunched in on this because resistant starch also helps to feed the gut bacteria, but technically it's not fiber. So there are certain types of fiber called prebiotic fibers, which effectively just mean a kind of substance that your gut bacteria particularly like to feed on, and then has a knock-on health effect. So these particular prebiotic fibers include things like inulin, oligosaccharides, galacto-oligosaccharides, and these are found naturally in onions, beans, asparagus, garlic, Jerusalem artichokes. And these types of fiber, your gut bacteria, it's like throwing them a field at a party. Kind of, they're having an absolute kind of festival in your gut when you eat these types of fibers. But I would say, generally it's, rather than kind of zooming in and focusing just on those types of thinking, okay, I've just got to think about these types of fibers. I really think it's actually just getting enough fiber in general and getting that variety, lots of different foods to contain a variety of different fibers. So we're talking about, again, those plant foods, fruits, vegetables, beans, nuts and seeds, whole grains, and just really trying to get that 30 grams that were recommended a day of fiber to really just help, health of your gut, but also your gut bacteria. And there's definitely a few tips and tricks, as I mentioned in my book, that we can do that are really easy and practical, that don't mean we need to think about it too much. We just make sure that these are the things that we can do on a regular basis.
Let's talk a little bit about, I would imagine you're familiar with the Stanford study from, I think it was a couple of years ago, where they took a bunch of people on the SAD diet, the standard American diet, and fed half of them a diet that was high in fiber, and then the other half that was high in fermented foods, and they graded them into it. And what they actually found, much to their surprise, was that lots of the people on the high fiber diet did really well and their inflammation went down, but some of them, their inflammation markers went up. And everybody on the fermented foods diet did better. And their hypothesis, I think from memory, was that basically if you've been eating a shit diet for quite a while, you have basically starved out the really beneficial microbes. And then when the lots of fiber comes in, it can be problematic for some people who have had that long-term crappy diet. But bringing fermented foods was like kind of fertilizing the entire gut. Did you see that study, and do you have any comments on it?
Yeah, so I think really what they was from what reading that study was that they felt that for the high fiber diet, that it wasn't a long enough time to really kind of see the benefits that they were expecting to see from the high fiber diet. And I think also they didn't necessarily look at the molecules that were being produced by fiber diet. So I think quite often, so there's other studies, for example, where they haven't seen a change in the diversity or the makeup of the gut microbiome, but they've seen that the metabolomes, the molecules that are produced can be completely different. And I think, again, with fiber, we do need to kind of very much think in a very individualized, personalized way that, it's a very much go low, start low, go slow. It's a stepwise approach where, if you don't want to go from 0 to hero, because then you're going to probably get uncomfortable symptoms, because we know that when your gut bacteria feed on fiber, they also produce gas as a side effect. So if you're going from 0 to hero, that can then mean that you're having, uncomfortable bloating, uncomfortable digestive symptoms. And if you've got a gut microbiome that is actually not very healthy profile, that might just be a period of change that you need to work on an individual way, being like, actually, I'm going to just slowly, softly increase this. So I think there was some interesting kind of comments around that being, why didn't they necessarily see such strong signals as they did in the fermented food arm. So in the fermented food arm, they effectively encouraged the participants to have 6 servings of fermented foods a day. This sounds very intimidating. It sounds very intimidating. Actually, I think we've got to really think about broadening that understanding of what fermented foods are. They're not just, kombucha and kimchi and kefir. For example, you can get fresh olives that are from a local producer or fermented foods. Cheeses are fermented foods. Yeah. There are a lot of different fermented foods. You can get also fermented other drinks and lots of different things as well. Like
miso soup as well, right? And anything that's in vinegar. So you're right. Yeah. There's a huge amount of choice. I am aware of time. So other than making sure that they're getting a lot of fiber and maybe introducing some fermented foods into their diet, what are your big recommendations around diet, both to do and not to do, presumably we should be decreasing our intakes of ultra-processed foods as part of this whole thing.
So I very much focus on adding things in, because I think naturally you then end up displacing who crowds things out. And I think that for me just feels, from a behavioral science perspective as well, is just, much easier for us to kind of stick to. It's much more encouraging, it's much more fun. And I think also for our gut bacteria, it's going back to that perspective of, okay, 95% of the nutrients from the foods you eat get absorbed in the small intestine. So a lot of the kind of quote unquote, theoretically kind of bad foods, which, I would say actually everything in moderation, and like a slice of cake's not going to do anything to your gut bacteria, is probably just going to be absorbed in your small intestine. So actually it's about getting the foods to your large intestine and making sure that you're getting enough of those fiber-rich containing foods, and also those fermented foods that then feed your gut bacteria, are the really key important things to be doubling down and focusing on. So I mentioned the prebiotic fiber foods earlier, but I think when we're talking about fiber, I find it really interesting because we're so fixated on protein, and yes, protein is important. And I think everybody kind of understands what high protein foods are. If I say to someone, what's a high protein food, I'm straight away say kind of meat, fish, eggs. But when we talk about fiber, we have a complete lack of understanding about actually what high fiber foods are. I think most people, when I ask them, will say maybe something like lettuce or salad. But actually, lettuce is a great example where actually it contains 1.8 grams of fiber per 100 grams, which, don't get me wrong, is fine. But in comparison,
not spectacular.
No, it's not spectacular. So if you think about, the chickpea fiber example, that contains 4 to 5 times more fiber than that lettuce does. Again, in comparison, we talk about nuts and seeds. Even just 2 tablespoons of chia seeds or flax seeds, that's 6 grams of fiber. Again, thinking about how you're swapping your bread is a really great, easy way to up your fiber content. So something called, the rye pumpernickel bread might not be your go-to everyday one of choice, but even just one slice contains that 6 grams of fiber. So that's, these really great easy ways. Yeah. So I talk about the BGBGs as being the kind of big high fiber hitters, and they're effectively beans, greens, berries, grains, and nuts and seeds. So dark greens tend to be, higher in fiber than a lot of other vegetables. Same with berries, because they contain those seeds in them, which give it an extra fiber boost. But again, these are both really kind of rich sources of other phytonutrients that are really important for our gut and our brain health as well.
Yeah, and I think that's really an important part. Is it's the whole food matrix that's really important, and we tend to zero in on little food components. So if you're eating real foods, yes, you're going to get a lot more fiber, but you're going to get a lot of polyphenols and flavonoids that do amazing things in our biochemistry. A couple of questions, last ones, because I am aware that you have to go and do an interview. So say somebody has an issue with, for instance, FODMAPs. Are they just going to struggle forever, or is that reversible by diet, by manipulation of the gut microbiome? Do we know anything on that?
Yeah, so if somebody's got a kind of FODMAP intolerance, that tends to be that they've got irritable bowel syndrome. And irritable bowel syndrome is a disorder of the gut-brain connection. And we think that there's very much a strong component of the gut bacteria in that. Again, this is kind of still evolving of our understanding of kind of how that relationship is. I think when thinking about low FODMAPs, so my work as a dietitian, I used to have a clinic for a while, and I would always, so far too often, see people coming in who have been on a low FODMAP diet for a year or more, and it's a very highly restrictive diet. And actually, really, you're only meant to be on it for, a period of 6 to 8 weeks, and then you work closely one-on-one with a dietitian to effectively try and understand which of the FODMAPs, because there's different types of FODMAPs, are the ones that are triggering you. And then also you can likely very much have some of those FODMAPs still. It's just maybe what are the levels that you can have, a dose for you. It's a bit like, filling a bucket with water. You can have some, but then it's when it overflows, that's when you're going to get symptoms. So it's very much a personalized approach. And I do think it's really important with the low FODMAPs to work with someone, because it is a very complex and personalized diet. And that then means that you're then able to still have that diversity of different foods that we know are really important, but still helping you to get that fiber in, but in a way that's helping you feel comfortable or it's not triggering your symptoms.
Awesome. Great answer. And that leads me nicely into the last question. So you talked about personalized, but that word's come up a couple of times. And I think it's really important because, when we see research study, the results are the averages, but there's lots of individual variations within that, right? But how far are we? I see something recently from a US company who does gut microbiome testing now talking about personalizing your diet and eating specific to your gut microbiome. How far do you think we are away from that in reality? And, for me, it's like, well, I mean, is that really what you want to do? Or do you want to be optimizing your gut microbiome through your food rather than eating in a manner that's going to support what's already there? What's your thoughts on this whole idea of personalizing your diet?
So I think we're really not quite there yet. I think there's a lot of, it's a bit of a wild west out there when it comes to microbiome testing. And I think when I say to people, if you, they're very expensive as well. And I say, if you want to know what bacteria you have in your gut, then that's what your microbiome test is going to tell you. If you're wanting to have any advice, special advice from that microbiome test, it's not going to give you what you're looking for, because the science is just not there yet when you're looking at a standalone microbiome test. And actually, it's really those broad pictures of what we talked about today. It's talking about that's relevant for everyone. It's talking about fiber, fermented foods, obviously according to what your taste preferences are, what makes your body feel good, whether you have, for example, an intolerance that we talked about earlier or not. But it's really that broad picture viewpoint of what supports your gut microbiome. And in a way, that's great, because then we get a variety of lots of different things, and we don't feel that we just have to eat red peppers for the rest of our lives. So that's so I think I've done a bit of research myself at King's where we've looked at kind of relationships with microbes and different foods. And I think we're just, we're seeing kind of signals, but I just think we're not quite there yet. And I think really what we need is to really, really understand and have much better viewpoints on, the nutritional composition of each of these different foods, to really understand, look at the different fiber contents of these different foods, and then just say, okay, well, actually really breaking down the different components and then see perhaps a relationship there. But I just think we're really not there yet. I would say that probably the next maybe 5-10 years, maybe we'll have more of an understanding. I'd probably say closer to 10 years. But in a way, do we really need to know that? I think it's got to be done in a way that's helpful, and it's not going to just make our diets then something that is kind of quite scary and intimidating because we think we've got to do X, Y, Z all the time, and it becomes hyper-focused, because then that's causing extra stress that's then having a knock-on effect from your brain down to your gut. So I think everything just needs to have a kind of perspective on it that's practical.
Yeah, look, I agree. I don't think we're there yet. And just the fact that you said earlier that we know that by tweaking your diet for 3 days, it can change the composition of your gut microbiome, tends to suggest that getting a microbiome test is just a snapshot of what it's like right now, and it might be tweaked a little bit depending on what you're eating in the next few days and how much alcohol and all that sort of stuff. So we don't know if it's completely stable, right? So I think basing your whole diet on a one snapshot is probably not the right answer. What is the right answer, though, is buying your book. So where can people go to find out about your book and your work and socials, all of that sort of stuff? Where do we send people to find out more?
Great, yeah. So my book is called Genius Gut, The Life-Changing Science of Eating for Your Second Brain. And it is effectively a simple guide to everything gut health, everything gut microbiome, from my perspective as, as I talked about, a microbiome scientist, dietitian, and also as a chef. So it's very practical. There are 10 simple hacks for your gut-brain connection, focusing on not just what you eat, but how you eat as well, for boosting your mood, your cognition, so being mentally sharp, and also just generally kind of feeling energized and feeling your best. So that is going to be available in Australia towards the end of the year, but it's available in the UK currently in all kind of major bookshops and Amazon. So I know I wrote it, so I feel like biased in saying this, but It really is everything that I've ever wanted anyone to know on your gut health in really practical terms that you can really put into place, and in a way that's also enjoyable according to what you like to eat. That's not just anything kind of wild and crazy. It's like, what are things you really want to know and need to know for your gut health? You can also find me on socials. So it's Dr. Emily Leeming, and my website is www.emilyleeming.com. And yes, and I actually should mention, I've got a free weekly email newsletter on the gut-brain connection called Second Brain that you can sign up either through my website or through Substack.
Excellent. Okay. So there you go, people. dremilyleeming.com, and go out and get her book, because who doesn't want a genius gut? Emily, this has been awesome. You are a true master of your craft, and put it across very eloquently as well. So thank you for giving up your valuable time. And I know that lots of people will have got lots of good things out of this. So keep doing your cool work.
Thank you. Thanks so much for having me.